sun again. Okay, right now we have Preston that's the sun. We're going to have it start over here with it angled like this. Now I'm going to keep it straight down, but let's see. Right like that, do you think it's summer or winter?
Winter.
Why would you say winter?
For who?
Because it's quite an angle it's hitting the earth at, right? It's not directly, it's kind of an indirect sunlight. Now, if I keep it the same way, and I move around here, I'm going to always try to keep it facing the same way. It's always spinning, of course, right? But I'm going to try to keep the tilt the same. Because the earth does keep about the same tilt all the time. 23.5 degrees, I believe, is the tilt of the earth. But we get over here, and now look at it. What's the angle it's hitting at? Almost direct, right at a 90-degree angle, right? Okay. We saw over there, it was hitting at a very low angle. Here it's hitting at almost straight from above. We're going to point it at the board now and see what difference that makes as far as energy goes. So point it right at the board. Stand right there and point it directly at the board. Okay. Let's adjust that a little bit so we can make it. I don't have to draw it big. Okay. See that right there? Back up just a little bit. If you can.
Excuse me.
Oh, no, actually, you were good like that. Forward. Okay, we're going to draw a square around the light. See that? That basically, that's all the energy from the light is going in that square, right? Now I want you to stay about the same distance, but I want you to go over there. Same distance, just different angles. So you probably can come in front of the board here. We're going to have a really low angle so you can exaggerate these changes. Okay. So you want to stay, let's see, 1, 2, 3. You were about 3 yards away, so I'm going to have you go about right here. 1, 2, 3, right here. All right. Okay, now shine it at the same spot. Okay. Here we go, lights on. What do you notice?
Got bigger.
So, this one right here, all the energy was over that area, right? But with the other one, it was in that area and it was spread out almost twice as much area with the same amount of energy. What does that tell you energy per square unit there?
It's low.
Half as much for the bigger one, right? There's half as much energy getting to each section in that square. Same with the seasons. During the winter, we're getting a lot less energy per unit because it's spread out more. It's hitting at a very low angle, going through more atmosphere, and it spreads that light over a greater distance, so you're getting less energy per square unit. That's why it's colder in the winter and warmer in the summer, simply because the sun's energy is spread out more over the winter than it is in the summer. Yes?
What is like the degrees of the tilt of it?
I think it's 23.5 degrees is what it's always tilted at. So depending on where it is, it actually does get farther and closer, but I believe the closest point is in January. So that would not explain the seasons, right? Because you'd think, well, when it's closer it'd be hotter, but that's not necessarily the case because distance is not as big of a factor because it doesn't get like 3 times closer than in the summer or winter or anything like that. It's not a huge difference in distance. But that's the seasons right there. Does that make sense?
Yep.
Okay. Good.